Welcome to this explainer. Look, if you've been hearing the term machine learning absolutely everywhere lately, and you want a structured, no-nonsense look at how it actually works beneath all the hype, well, you are in the exact right place. Today, we're going to unlock the true mechanics of how these systems actually learn.
We've got a lot of ground to cover, so we're breaking this down into 5 parts: decoding machine learning, a roller coaster history, the 7 steps of ML, avoiding model mistakes, and finally, the quest for fairness.
All right, kicking things off with part 1, decoding machine learning, from the human brain to the algorithm.
So people toss around the terms artificial intelligence and machine learning like they're the exact same thing, but actually they aren't. AI is the big overarching concept. It's programming a machine to mimic intelligent behavior. Machine learning, on the other hand, is a very specific subset of that. It's using algorithms to uncover hidden patterns from data so a computer can make rational decisions. Basically, if AI is the grand destination, ML is the engine getting us there.
To really get this, think about a toddler exploring the world. As they grow, they perceive their surroundings, and they gradually learn these hidden patterns that help them craft logical rules to navigate life. Machine learning is inspired by that exact process. While the human brain relies on life experience, machine learning relies on math. It applies mathematical algorithms to huge piles of data to achieve that same kind of continuous learning.
Moving right along to part 2, a roller coaster history, decades of ambition and AI winters. It is so easy to think of machine learning as this brand new tech fad, right? But honestly, this whole quest relies on math from way back in the 1700s. Hello, Bayes' theorem. The ambition actually peaked surprisingly early. Just look at mathematics professor John McCarthy at the 1956 Dartmouth Summer Research Project, which, fun fact, is where the term artificial intelligence was officially coined. Back then, the optimism was absolutely sky-high. But man, it hasn't been a smooth ride. Alan Turing laid the groundwork in 1950, sparking those super optimistic golden years. But then reality hit. Between 1974 and 1980, funding just dried up, and we entered what's known as an AI winter. Why? Well, because of a combinatorial explosion. The math got way too complex, and we simply didn't have the computing power or the data to back it up. It wasn't until the internet and smartphone explosion between 1993 and 2011 that our technology finally caught up to our ambition.
Which brings us to part 3, the 7 steps of ML, empowering the mechanics.
So how do we actually build one of these things? Creating a machine learning model follows some surprisingly logical mechanics. Step 1, you've got to decide on the exact question you're trying to answer. Step 2, collect and prepare your data. And a quick aside here, this is absolutely crucial. The quality of your data dictates your success. Feed a model garbage, and you are going to get garbage right back. Step 3 is choosing your mathematical algorithm, and Step 4 is where the magic happens, training the model on your data so it can discover those hidden patterns. But we don't just train it and walk away. Step 5 is evaluating the model. We test it using a completely separate set of data that the model has never seen before, just to see how it performs in the wild. If it's a bit off, we move to Step 6, parameter tuning, where we essentially tweak the dials and settings of our algorithms. And finally, Step 7 is the ultimate goal, predicting outcomes on completely new, real-world data. Now let's clear up some jargon really quick, because understanding the language here is key. When we feed data into these models, we break it down into features and a target. Features, which we usually represent with a letter X, are your inputs. These are the measurable variables, things like date, size, or color. The target, represented by the letter Y, is the exact outcome you want to predict. So for example, if you're trying to predict real estate prices, your features might be the square footage and the neighborhood, while your target is the actual dollar price of the house.
All right, part 4, avoiding model mistakes, specifically the fitting problem.
When you're evaluating your model, you are going to run into 2 massive pitfalls. First up is underfitting. This is when your model is just way too simple. It fails to learn the data properly and performs terribly. The flip side of that is overfitting. This happens when a model memorizes the training data a little too well, including all the random, meaningless noise. It's like a student who memorized a practice test but completely blanks on the actual exam. When you show an overfitted model new data, it totally falls apart. So a great data scientist is constantly doing a balancing act between these 2 extremes. And finally, we reach part 5, the quest for fairness, focusing on responsible AI in society. Now, I really want you to think about how these models impact us every single day. If our training data is missing certain demographics, or if it just reflects historical human biases, the model is going to inherit and amplify those exact same biases, and that leads to real-world unfairness. It can impact who gets approved for a loan, it can affect quality of service. I mean, think about automated soap dispensers that literally fail to detect dark skin just because the training data wasn't inclusive. It can lead to denigration, where image labeling tech mislabels people of color, or stereotyping, where translation software automatically assigns specific genders to certain professions. These are very real, very tangible harms.
So how do we fix this? We have to design for trust and accountability from day one. That means prioritizing reliability and safety, especially in those weird edge cases. It means building inclusive systems that actually empower everyone. We have to fiercely protect data privacy. And crucially, we need transparency. We really have to ditch this mysterious black box mentality where we don't know how the AI thinks and instead adopt a glass box approach. We need to be able to clearly explain why a model made the decision it did so we can debug it ethically.
We've journeyed from the raw math of the early pioneers all the way to these incredibly complex systems that are literally governing modern society, which leaves us with this one final, provocative question for you to chew on today. As the first generation to roll out AI to society at this massive scale, how do we ensure that the people designing these powerful computer systems remain fully accountable to everyone else? It's a huge question, and one we absolutely have to keep asking as we continue to unlock the incredible power of machine learning. Thanks so much for joining me on this explainer today. Keep asking those great questions, and I'll catch you next time.